Time for our weekly sci-fi segment. Welcome to the Sci-Fi Show on GameSHOUT.
Welcome back to GameSHOUT Radio. This is Science Thursday with your host, Soulrift. Oh yeah, it's time to do some...
Yeah.
Oh yeah.
Well, sorry. Couldn't resist. Had to give you an yeah.
Well, it's time to cover all sorts of really exciting science news. I've been digging up a lot of the space news. If you've been following our show or listening to the podcasts, we had a big show on hyperspace last week, and so I thought I'd fill in with a whole lot more little tasty tidbits of space news. I've also got a very fun little invention that should interest you if you're going to go diving near any secret and secure military sites. But first, you know, keeping with the whole wacky news theme and glow-in-the-dark pigs, well, it's not just farting cows, glow-in-the-dark pigs, and Mav's family that spew out methane.
Hey, I told you that in confidence that my brother makes a lot of methane after my wife's chili. But hey, you know... Oh, jeez.
You know, I'm sure you two just sit there by the dinner table trying to outdo each other. Have these sort of farting contests.
No, never at the dinner table. We're more couth than that. We sit in the living room and do it.
By the fireplace, of course.
That's right, by the fireplace. Yeah, we used to do it with snifters of brandy and cigars.
Well, you know what? Living plants have been disgorging millions of tons of the potent greenhouse gas into the atmosphere every year without anyone even noticing. You see, the concentration of methane in the atmosphere has almost tripled since pre-industrial times. Environmental scientists thought they had identified all natural sources where bacteria convert organic plant matter to methane, you know, such as swamps and wetlands and rice paddies. These bacteria thrive only in wet, oxygen-poor environments. They cannot survive in air. So Frank Kepler, an environmental engineer at the Max Planck Institute in Heidelberg, Germany, was surprised when he saw the signs of methane being emitted by plants he was examining in normal air. If we were following the textbook, we would have ignored it as a mistake, he says. But Kepler and his colleagues decided to investigate further. They measured the amount of methane given off by plant debris, bits of grass and leaves from local and tropical plants, in a methane-free chamber. To rule out the possibility that bacteria were at work, they bombarded the plants with gamma radiation to sterilize them. The team saw similar levels of methane produced by both sterilized and unsterilized leaves. We realized that we were looking at a previously unrecognized process, says Kepler. They still don't know exactly what is happening, but believe that pectin, a substance contained in a plant cell walls, plays a part in the methane-making mechanism. Now, when the group repeated the tests with living plants, they were stunned by the amount of methane created. They estimate that globally, living plants produce between 63 and 236 million tons of methane per year, with plant debris adding only 1 to 7 million more. This would make plants responsible for roughly 10 to 30% of global methane production. The effect is completely missing from climate change and bioecological models, says Peter Cox of the Centre for Ecology and Hydrology at Windfrith in Dorset, United Kingdom. He suggests that a new source of methane could help solve some climate mysteries. One such puzzle was posed last year when satellite observations revealed that the tropical rainforests are emitting more methane than expected. So, you know, there you go. The culprit for methane, it's not the cattle, it's not Matt's family, it's all those pretty little plants.
Thanks, pal. I owe you one.
Yo, yeah. Well, you know, jumping from methane-creating plants out into outer space, I've got a lot of fun news here I'm just eager to dive into. Now, if you've been following any sort of astronomy, you've heard about these really cool planets or stars called pulsars or neutron stars that spin around really fast and emits pulses of energy as they go around. Well, the fastest spinning neutron star ever found was recently discovered in a crowded star cluster near the center of the Milky Way galaxy. A new study has shown that this star rotates 716 times per second, faster than some theories predict is even possible, and therefore may force researchers to revise their models. Now, neutron stars form when a massive star explodes at the end of its life and leaves behind a super dense spinning ball of neutrons. These stellar corpses emit intense beams of radio waves from their poles and are thus called pulsars. Most pulsars rotate just a few times per second. You can imagine here, something the size of a star rotating around a few times per second. These things spin around really fast and emit a lot of energy. But some of these pulsars here spin hundreds of times faster. These so-called millisecond pulsars whip around so quickly that because they are thought to have stripped mass and angular momentum from companion stars at some point in their histories. Maybe you've seen these images of sort of one big star rotating around a little tiny star and the star matter being sucked down into it. Yeah. Very popular image. Well, that's
the black hole.
Well, sometimes they're black holes, and sometimes they're just super dense remnants of stars, such as neutron stars, pulsars, different things like that. But anyway, the astronomers led by Jason Hessels at McGill University in Montreal, Canada, used the 100-meter Green Bank telescope in West Virginia to clock the newly discovered pulsar at 716 rotations per second, or 716 hertz. The previous record holder, which spins at 642 hertz, was discovered in 1982. The new discovery, called PSR J1748-2446AD, is interesting because it spins faster than 700 hertz, which astronomers had considered a stellar speed limit. Although most pulsars should have enough self-gravity to spin as fast as 3,000 times per second before they tear themselves apart, all of the previous discovered millisecond pulsars, of which there are about 150 or so, spin slower than 700 hertz. This led researchers to believe that they were emitting gravitational waves, theoretical ripples in space-time that kept their spins in check. Massive, fast-spinning objects that are not perfectly symmetrical are predicted to radiate away energy in these waves, with faster objects unleashing much more energy than slower ones. Now, Brian Jacoby, a pulsar expert at the National Research Council in Washington, D.C., and not part of this discovery team, says the brick wall effect is thought to be very effective at limiting spin rates. If you make it spin just a little bit faster, you're emitting a lot more very strong gravitational waves. So the existence of this pulsar suggests that the numbers for the speed limit aren't quite right, or that something is wrong with this idea of a speed limit in the first place. Now, the authors of the study agree, saying that the slowing from gravitational wave emissions must become significant either at spin rates higher than 700 hertz, or that the theorists should revise their model of neutron star crusts, which were used to arrive at that 700 hertz speed limit. So this pulsar's speed means that it would fly apart if it was larger than 16 kilometers across. So this thing is really tiny, and yet they estimate its mass at about twice that of our sun.
Wow.
Yeah, so this is a star that's got twice as much mass as our sun, and it's, you know, smaller than a small city. And it's spinning like 700 times a second.
That's like scary, you know?
Yeah, these things are just so powerful. It just boggles the mind. There's nothing like that in our solar system, nothing. And the amount of energy that these things contain, if we could, you know, harness one of these as a fuel source, it would be far greater than, you know, anything in our entire solar system produces. I mean, it would be like having something even stronger than our sun at our disposal. So you can understand why a lot of scientists want to get their paws on a neutron star and build something like a Dyson sphere around it.
Yeah, I mean, but is that how they'd contain it? I mean, how would you know, like...
Now you're getting way into the realm of science fiction, which is always fun to speculate. But the
I wanna
theory is that if you
speculate
build
a How do you think?
if you build a giant metal sphere around one of these spheres, around one of these stars, it's only maximum 16 kilometers in diameter. So you'd only have to build a metal sphere about maybe 20 or 30 kilometers in diameter, and then of course you can trap all that energy, all that radio energy being emitted from the pulses, all the gravitational waves, and it's all at your disposal.
Or if you're
Very
really cost
cool.
effective, just build a ring world.
Yeah, well, the thing is that you can either build the ring world, but you definitely want to reach all the way up to the northern and southern poles to get the radio wave emissions, and also around the equator to get the gravitational wave emissions. So you'd have to build sort of two rings, one that go around longitudinally, one that goes latitude, right?
Yeah. Which would still be cool.
Yeah.
A dual
Still be
ring.
cool. Maybe 3 rings, just to make it look sort of symmetrical from all angles.
Well, then they could be their own. They could be their own shadowing. I mean, have you ever read the Ring World books from what's his name? The name is now eluding me.
Oh no, I've never read those ones.
They're really good books, and they actually they went through scientifically to figure out how Ring World would work. And actually, in some respects, I think having multiple ring worlds around would actually work in a different perspective. However, the only problem you'd run into is an unstable gravitational pull could crash the ring worlds into each other. So basically, you're better off probably just building a Dyson sphere.
Yeah, Dyson sphere is the way to go. Then you get to trap all of
I'm
the
with
energy
you.
because you cover the entire
Save the
surface of
energy.
it.
As
Yeah,
long as you don't
exactly.
go careening into the sun with the Dyson sphere, which would be bad.
That'd be very bad.
Yeah, the idea with the Dyson sphere is, of course, because you're covering the entire surface of the star, you've got equal amounts of gravity pulling on all points of the Dyson sphere, and it stays stable around it.
Well, unless the
At least
sun
that's the
goes
theory.
unstable. That's the theory. No, wait. Correct me if I'm wrong. With a Dyson sphere, is it habitable to live on the inside of the sphere facing the sun, or is it habitable to live on the actual inside of the sphere, where between the outside and the inside, or the outside? Yeah. Do you know what I'm saying?
Yeah, well, the original plans for the Dyson sphere was that you would build a metal sphere at the Earth's orbit around the sun. So it would be a sphere that would be the Earth's orbit across, and so the inner surface of the sphere would receive the sun's rays at the same intensity that the surface of the Earth receives the sun's rays. Therefore, you'd actually live on the surface of the sphere looking up at the sun, and you'd have that entire inner circle of the sphere as habitable surface.
Okay. You'd also need an atmosphere to be able to support that much mass. I mean, that much land mass to live on a Dyson sphere.
Well, of course, the actual mass of the sphere itself would produce enough gravity to trap an atmosphere, but the amount of matter that would be required to construct a Dyson sphere is more than I think is currently present in our galaxy, or at least in our solar system. But
Well, I
this
think
Dyson
in the
sphere,
galaxy overall, it would work.
yeah, it would take more mass than actually exists to actually build one. But the Dyson sphere that I'm referring to would actually be more of a power source sphere that you'd build very close to a very powerful pulsar. The inside of the sphere would be highly irradiated. You can never actually live in it, but you could use it merely as a power-producing device.
Hey, Andy, for Christmas, forget the bonus check. Just get me a Dyson sphere.
Yeah, I want one too.
Oh, there
If
you
you
go.
order,
Well, you know
if
the,
you order two, you might get a discount.
buy two get one free.
You know, on
Yeah.
Wikipedia, there is no coverage on the Dyson sphere.
Oh, well,
That's
let's
kinda
just go up there and write
surprising.
something.
I mean, like, the sad thing is, most of what I know of the Dyson sphere, I've gleaned from, a few science reports here and there, but mostly the one episode of Star Trek: The Next Generation.
Yeah. Well, you know what?
Oh,
If
I
you do
haven't seen
want, if you do want multiple Dyson spheres, all with this sort of power source, this particular pulsar was found in a cluster of 10 billion-year-old stars called Terzin 5, which lies around 28,000 light-years away, closer towards the center of the galaxy. Now, Terzin 5 contains 33 known millisecond pulsars, the highest number in any known star cluster. So if you want, you can get up to 33 of them in this particular star cluster just by going a mere 28,000 light-years away.
28,000, that's nothing.
That's nothing, no. But if you want to go even further, 2.7 million light years away, that'll go right out of our galaxy and towards the our nearest galactic neighbor, Andromeda. Now you see, this is another very interesting thing that was recently discovered with astronomy. Most of these small satellite galaxies around the Milky Way's near-twin Andromeda are lined up in a single plane that slices through Andromeda's spiral disk. Now this alignment suggests that the satellites are either floating on a river of dark matter or are the remains of a larger galaxy Andromeda has already cannibalized. Astronomers have known for about 25 years that the Milky Way's dozen or so satellites line up along two planes that lie perpendicular to the disk. Now that means if you imagine the disk goes around and then you slice it in half from top to bottom, that's where all of our satellites line up. But the structures formed are, they're still not clear why they form up in these slices. So a team led by Eva Gebrel of the University of Basel in Benningen, Switzerland, set out to discover whether similar planes exist around Andromeda. At a distance of 2.7 million light-years, Andromeda is the nearest large spiral galaxy similar to the Milky Way. The researchers plotted the positions of Andromeda's 14 satellites using the images from the Hubble Space Telescope and found that 9 of them lay in a relatively thin plane, only 52,000 light-years wide. It's unlikely that such a plane would arise by chance, Gabriel says. The satellites in the plane also shared similar characteristics. Most were faint, low in mass, and had already stopped forming stars. So the team believes that the plane could have formed in several ways. In one scenario, the galaxies may have fallen towards Andromeda along an invisible filament of dark matter. Computer simulations show how these filaments can form a cosmic web along which galaxies flow. Distant observations show evidence for the filaments, since maps of the universe's large-scale structures reveal thousands of galaxies lining up along intersecting streams. But such filaments have not yet been detected near the Milky Way. One question is, could we see such a filament in our immediate surroundings? Could we finally track down and find some dark matter? Now she says that two fairly significant masses do lie on either side of Andromeda, with the spiral galaxy M33 on one side and a group of 36 galaxies called M81 11 million light-years away on the other. If a dark matter filament connects all three, Gabriel says that future observations may show Andromeda's satellites moving along that filament. But dark matter is not the only explanation. Alternatively, the satellites may represent the remains of a more massive galaxy that was torn up and partly digested. When that galaxy began to interact with Andromeda, it could have broken up into smaller pieces, with some falling into the larger galaxy and others surviving. If this is correct, we should see these have maintained the orbit of the original galaxy from which they came from, and we should see something that moves along this plane. Unfortunately, because of Andromeda's distance, our current telescopes cannot measure such subtle motions, so we'll have to wait for future star mapping satellites to be launched within a decade. So those are our looks at some.
I don't want to wait.
So base. Well,
I don't want to wait. I want to know now.
Maybe find.
Sorry.
Well, I can't tell you now. We don't have any satellites that can say now. But this does show, maybe we finally found some physical evidence of dark matter, and it may give us a good idea of where we should point our telescopes near our own galaxy and get a look at this stuff, if we can actually find it. Well, we've got to take a quick break here on the Science Thursday show, but when we come back, we're going to look at whether or not gamma-ray bursts could rule out Einstein's cosmological constant entirely. And we'll be back with more science right after this.
You're listening to GameSHOUT Radio. Want to stay, well, in touch with Nintendo DS news? Don't sweat it. GameSHOUT's your answer. Tune into the Pocket Players Nintendo DS Edition mini podcast, and you'll feel right at home. What's new in the dual screen world? GameSHOUT knows. Is this game any good? GameSHOUT can tell you, man. I want to know more about this one game coming out soon. Well, GameSHOUT's on top of it. So be sure to find out more about the games, news, previews, and reviews that matter from the only gaming site that matters. You guessed it. GameSHOUT.com.
Hey, welcome
Millions
back
of
to
people
GameSHOUT
love
Radio.
Newegg.com. Go on that website and check it out. You'll see what I'm talking about. There's a whole testimonial page. People are using the L word when it comes to Newegg.com. They say love. I love Newegg.com. How is Newegg.com earning this kind of devotion? Well, they sell computers, components, and electronics. That's true. But it's the great price. It's the huge selection. It's the fair shipping. And it's because the customer service is so great. They actually care about your satisfaction. They have video cards, routers, wireless networking equipment, DVD players, hard drives, software, digital cameras, and unbelievable fair shipping. So, I can't sing the praises of Newegg.com enough, and neither can anyone else. So whether you need a motherboard or the mother of all TVs, go to Newegg.com. You'll see what their millions of happy customers are raving about. Once you know, Newegg.com.
Or more distance than expected, given their redshift, which measures how much their light has been stretched by the expansion of space. But it's still not clear what exactly dark energy is. And so far, supernovae studies have supported the cosmological constant. One recent study of 70 supernovae reported that the strength of repulsion given by dark energy could not have changed by more than a couple percentage points over the past 8 billion years. But supernovae are too dim to be seen over the largest cosmic distances. Some astronomers argue that gamma-ray bursts, violent, fleeting explosions that accompany the deaths of some massive stars and quasars, are better signposts. At about 100 times brighter than supernovae, they can be seen at much greater distances. So, the astronomer Bradley Schaefer at Louisiana State University in Baton Rouge has used observations of 52 gamma-ray bursts to suggest that dark energy has changed over time. The largest of the gamma-ray burst study of its kind, Schaefer found out that 12 of the most distant bursts, lying nearly 13 billion light-years away, were all brighter than expected, suggesting that the universe was expanding at a slower rate then than it is today. He says that the fact that all 12 were brighter would be predicted by a cosmological constant increases his confidence in the data. It's like if you flip the coin 12 times and gets 12 heads in a row, he says. So he says that rather than pushing space apart, dark energy appears to have changed over time and was in fact drawing space together in the early universe. What that means for the fate of the universe is still not clear, but it seems that he's opened up a whole Pandora's box of outlandish possibilities for dark energy. So, you know, this is an interesting fate of dark energy, but a lot of other scientists aren't convinced. They say that the type 1A supernovae, which are analyzed for measuring the acceleration of dark energy, they all explode with the same intrinsic energy, making them ideal sort of standard candles to measure the distance. But gamma-ray bursts explode with a variety of energies. So although he measured 5 different properties of the bursts, such as how their brightness changes over time to estimate their intrinsic brightness, it's still not sure whether these are accurate ways of measuring distances and the acceleration of space at very far distances. So the scientific community is still out whether gamma-ray bursts have gotten rid of Einstein's cosmological constant, or if we're just going to be stuck with supernovae and measurements of slightly shorter distances. But going from the furthest distance of the galaxy...
I guess the question is, will we live if one explodes in our pocket? Okay.
Well, you know, thankfully we don't have any quasars in the Milky Way galaxy. We probably won't be experiencing any gamma-ray bursts anytime soon. No, we would not live. If something like that blew up in our galaxy, all life on Earth would just be evaporated. These things are pretty powerful. Yep, pretty much like that. It's like a giant wave just going whoosh, and there you go, we're all gone. Well, that could happen again pretty soon because the U.S. has officially notified the United Nations and the United Atomic Energy Agency that NASA is preparing to launch New Horizons, its Pluto-bound mission, carrying 10.9 kilograms, or about 25 pounds, of radioactive material. The New Horizons probe is scheduled to begin its 9-year journey on the 17th of January. It's carrying plutonium dioxide to power its instruments during its frozen odyssey through the solar system. Now see, NASA says that it needs plutonium for New Horizons because, of course, it's heading for Pluto. Going to Pluto, you need plutonium. Not because of the name, no. It's because solar arrays would not provide enough power that far away from the sun. As New Horizons reaches the 9th planet, the solar illumination would be less than 1/1000th of the expected solar energy near Earth. However, the big worry at this point is that there could, of course, be a launch accident involving the release of plutonium dioxide into the atmosphere, and it says that there's a chance of about 4 in 1,000 that this would actually happen. Thankfully, if there is a launch accident, the U.S. would offer to help clean up of affected nations. I can't get over that. We'll accidentally, spill 25 pounds of radioactive goop on your country, and then we'll offer to help clean it up. Well, at least they clean up their messes, right?
I guess.
And finally for us tonight, hopefully if you won't get smattered with radioactive goop from the new Pluto mission, maybe you'll go diving instead. And if you are scuba diving, make sure not to swim anywhere near a ship or installation that has been protected by the Raytheon Corporation's new swimmer denial system. See, Raytheon's underwater sensors detect any unwelcome presence and trigger an underwater sound system that emits extremely powerful pulses of low-frequency audio. The pulse rate and audio frequency are chosen to make the human organs resonate like organ pipes, causing swimmers to vomit into their masks or suffer internal ruptures.
Ow! You're just bad. Oh, bad.
Oh my goodness, I just could not believe it. The idea of blasting very powerful sound at underwater targets is not new. It can even be used to detonate incoming torpedoes, but it can also cause havoc with marine life. Well, the Raytheon system is supposed to be greener because the main sound projector in the middle of the secure zone emits sounds with a power and frequency that are relatively safe. A dozen or so secondary projectors in a ring around the zone also emit safe pulses. But in the region near each secondary projector and the main and secondaries combine to produce a sound... between the main and secondary projectors, the sounds combine to produce a sound which is decidedly dangerous. So would-be spies or terrorists cannot get through the ring, but there would be no widespread danger to fish, dolphins, or whales because they'd probably be scared away by the sounds made by the outer ring of emitters. Well, that's one way of protecting our coast. We build a giant ring of nasty sound sensors around the United States, so if any terrorists try to swim in, they'll get their internal organs shaken up and exploded.
Oh, yeah. Yeah, that's wow.
Wow is an understatement. But, of course, that's about all the time we have for our entertaining Science Thursday show. Be sure to stay tuned for a whole lot more from GameSHOUT Radio, and this is Soulrift signing out.
This is GameSHOUT Radio, the #1 talk game station in the world. Visit GameSHOUT.com for more info. GameSHOUT.